All right, hey there, POA students. Let's take a look at this homework for 3.4. We're going to do a little bit of work that has us evaluating expressions, thinking about variables, and combining like terms. We did a lot of stuff in class today. There were quite a few different skills we tried out, and so we're just going to try to review those through the homework. So we're considering this rectangle shown. It has, it seems like, a width of 5 and a length of x plus 2. I'm just looking at it here. It says find the length of the rectangle if x equals 10. And so the way that the rectangle is drawn, this x plus 2 means that we don't actually know the length. But since they are telling us that x equals 10, that's going to let us know that this length isn't just x plus 2. We can replace the x with 10. So that's 10 plus 2, and that's going to give me 12. I'm going to put my work over here as well. 10 plus 2 equals 12. So the length of the rectangle is 12, so long as we know that x is 10. All right, find the perimeter of the rectangle if x is 10. And so perimeter means that I have to find out the total distance all the way around. I'm going to kind of highlight that here. We have to do this side plus this side plus this side plus this side. And we'll look at that again here. So I know that since this side is 5, that this side has to be 5 as well. And since this side is 12, I know that this side has to be 12 as well, because opposite sides in a rectangle have the same length. And so now I'm going to go ahead and start trying to add it together. So I have 5, and that is this side, plus 12, and that is this side, plus 5, and that is again this side, and then plus 12, and finally that's this side. And if I add all those together, 5 plus 12 is 17. 17 plus 5 is 22. And 22 plus 12 is 34. So there is my answer. The perimeter is 34. Write an expression using the variable x to represent the perimeter of this rectangle. Okay, so they want us to go back to thinking about this as though we don't know what x is. And so since x plus 2 is there, I know that x plus 2 must also be up here on this side, because those sides are similar. And so here's how I'm going to try to tackle this. I'm going to have those two sides. I'll have 5 to start with, which I'll highlight in orange. That's 5. And that's what I highlighted in orange, plus x plus 2. And that is highlighted in blue over there. That's this side. And then I'm going to add 5 again. And that's this side here. Plus x plus 2. And that is this final side up here. And so now I can look at this, and I have to try to maybe simplify it a little bit. I'm going to get rid of this label for the length here, so I have some more room to work. I'm going to simplify that, and so the way that I'm going to simplify that is to identify the terms that are alike. And so I'm actually going to get rid of some of my highlighting here so that I can do that. And I'm just trying to demonstrate things here to you. When I'm looking at this expression, I see some terms that are just numbers. I'm looking at 5, 2, actually plus 2, plus 5, and plus 2. And so I have 5 plus 2, 5 plus 2 plus 5 plus 2. So 5 plus 2 is 7. 7 plus 5 is 12. 12 plus 2 is 14. So that gives me 14 from the terms that I've highlighted in red. And then I have a couple of terms like plus, whoops, let me get my green highlighter, that's what I was looking for, plus x and plus x. Those are going to give me, x plus x gives me 2x. So I have 14 plus 2x for my expression, and that's what I should end up with. All right, so now they say evaluate your expression from part C for x equals 10, then compare the result to your answer for part B. And so I'm going to take my expression 14 plus 2x, and I'm going to rewrite it now that I know that x is 10. And so I'm going to rewrite, I'm going to do 14 plus 2, and when I get to the x, I'm going to replace that with a 10. So now I use my order of operations. I do multiplication first. That's 20. So that's 14 plus 20. And then I add 14 plus 20 equals 34. And they are equal. I'm going to highlight the things that I think are equal here. 34, I got the same answers I did for part B, and that's what it asked me to compare. All right, one problem down. Let's look at the next one. All right, write expressions for the perimeter and area of the rectangle. Let's see. So perimeter means I need to go all the way around, and so I'm going to remind myself that if I go across, this should be x, and this should be x plus 10. And so I'm going to zoom in quite a bit here. Let's do the perimeter right here. And so the perimeter asked me to go all the way around the rectangle. And so I'm going to do this side here. That's x plus this side here. That's x plus 10 plus this side plus x plus this last side, which is plus x plus 10 again. And so now I identify like terms. I have an x, an plus x, plus x, plus x. So those are all the things that are the same variable. So x plus x plus x plus x, that's 1, 2, 3, 4 of them. So I'm going to rewrite that as 4x. And then I look at my other like terms, to highlight in orange, plus 10 and plus 10. Neither one of those has a variable. And so I get plus 20. And 4x plus 20 is done. You can't combine those to make 24x or something like that. This is my final answer for the perimeter. Okay, so perimeter, we have to add everything up. Area, which it also asks us to find, you have to multiply. So area is a multiplication problem. It is this side times this side should give me my area. So I'm going to write that x times x plus 10. And some of the practice we did in class today is to notice that since this is the distributive property, I can actually divide my rectangle up, and we'll see that. So since it's the distributive property, the length down here is broken up. It's broken up into a chunk that's x and a chunk that's 10. And so if I multiply, x times x is part of it. That gives me x squared. I'll put that work down here as well. And I have 10 times x from the 10 here and the x here. 10 times x gives me 10x. So this is going to be plus 10 times x and then plus 10x. So my final area is x squared plus 10x. Because x times x is x squared and 10 times x is 10x. And so one of the things we're trying to get used to is knowing that it's all right not to know everything. And that's what variables are kind of all about. So we're trying to get comfortable with the idea that we can give an expression for the area even though we don't know the numbers that make up the length and the width. You can think back to some of those room problems we did today. Write expressions for the perimeter and the area of the rectangle. Okay, so we have to do the same kind of work. Let's start with the perimeter. And so we have to add up all the sides. I'm going to start with this side. So that's 12 plus this side. And I see x minus 2 plus this side. And that should be 12 again. So I'm going to add 12 plus the final side here, which is x minus 2. Okay, so we've got our expression. We need to find some like terms. I see 12 minus 2 plus 12 minus 2. Those are all things that have no x's on them. So 12 minus 2 is 10. I guess maybe that's not a good way to write that since we use that notation for something else. 12 minus 2 is 10, plus 12 is 22, minus 2 is 20. And so I should get 20 for those terms. And I got those from the orange ones. Let's use a different highlighter for the x term. So I see plus x and plus x. That's 2 x's. Because I have an x and an x, that makes 2 x's. That's plus 2x. And I get those from the ones I've highlighted in red. And I'm going to scoot that up just a little bit And so that's my final expression for the perimeter. Whoops. There's my final expression for the perimeter, 20 plus 2x. So now let's find the area. You may notice I'm doing my best to try to keep my work organized, and if somebody were reading my work, they'd be able to see exactly what I'm finding because I labeled it with area. All right, so I'm going to erase this writing and the highlighting here. I'm going to notice that the width is kind of broken up into an x and a -2 portion, and that doesn't quite make sense because it can't have a distance of -2, but we're going to use it just for the fact of the model. So I should get something that looks like 12 times x minus 2. That's how you find an area. You multiply the length and the width. And so it breaks up into two multiplication problems. There's 12 times x here and 12 times -2 here. 12x is what you get from 12 times x. And 12 times -2 is -24. And so I'm going to put that work here as well. Plus 12 times -2. So I get 12x plus a -24, which looks a little clunky because plus a negative looks weird. So I'm going to rewrite that as 12x minus 24 because adding a negative is the same as subtracting. And so there is my area. All right, 3 problems down, we're on our way. Sarah and John found expressions for the perimeter of this rectangle. Their work is shown below. Who is correct, Sarah, John, or neither? Explain your answer and correct all incorrect work. All right, so they're finding the perimeter. The perimeter, I know you mean you have to add stuff up. So let's see, I'm going to use my highlighter and see if I can figure out what each part represents for each person. So 3x, that looks like 3x right there. X plus 7, that looks like x plus 7 here. There's 3x again, and x plus 7. So it does not look like Sarah made a mistake there because she added up all 4 sides. Let's see if she did the right thing when she combined her like terms. And so I'm going to erase my highlighting here. Let's find the like terms. I see 3x plus 3x plus x. And so that's 3x plus x is 4x, plus 3x is 7x, plus x. I think that means that we have 8 x's, and so there is an error that Sarah made. Let's see if she did a good job with the other terms. Plus 7, and I get 14. So I should get 8x plus 14. So Sarah made a mistake when she added up the x's. I'm going to write Sarah was incorrect because 3x plus 3x plus x is 8x, not 6x. Okay, so let's look at John's work and see what he thought. All right, so I see 2 times x plus 7, and x plus 7 sure seems like it's coming from here. And I'm trying to think of where that 2 comes from. And I think it might come from here. This side is x plus 7, so there are 2 sides that are x plus 7. So maybe that's where John thought that 2 came from. Let's see if we can parse out this. There's 3x and 3x, and he's multiplied it by 2 again. It sure seems like that 2 comes from the fact that there are 2 sides, this side and this side, that are both 3x. So that looks okay so far. Let's think about what 2x plus 7 is. So I'm going to zoom in here. We're going to check John's work because this part looks okay. So let's check his arithmetic. So I'm going to check 2 times x plus 7, and I'm going to draw our rectangle for that. X plus 7. So that means there's an x area and a 7 area. So this is 2 times x, that's 2x. This is 2 times 7, that's 14. So I get 2x plus 14. Okay, is that what John got? I see the 2x, but he got plus 7, so that seems wrong. Let's check the other part. 2 times 3x, that is 6x. And so when he did this, he should have gotten 2x plus 7, 2x plus 14 plus 6x. And so there is his error. He didn't put that 14 when he should have because he forgot to multiply 2 times 7. Pretty common mistake. And so you should get 8x plus 14. And so I'm going to write a little sentence down here after I can zoom out. I'm sorry about my sniffles. John was also incorrect because 2 times x plus 7 is 2x plus 14, not 2x plus 7. All right, so they were neither correct, and we've also corrected both of their answers. And what I like about it is now both of the perimeters are both the perimeters are the same, which is exactly as it should be. Since they're the perimeters of the same object, you should get the same expression. All right, let's do this staying sharp. Complete the square box problem. So you multiply to get the top, you add to get the bottom, and so we have two pieces of evidence. We need 3 plus something makes 5. I'm thinking to myself, 3 plus 2 makes 5. And so then I have to do 3 times 2 equals 6. And there it is. Simple enough. The steps of the magic number puzzle are: pick a starting number, square the number, subtract 2. Follow the steps to complete this table. Ooh, this is going to take a lot of work, it seems. So I'm going to try to zoom in quite a bit, and I'm going to try to remember that we square the number, then subtract 2. And I'm actually going to kind of like write into the paper here in the middle. And I'm going to try to ignore that center line here. I'm just going to kind of write over it. I know it's going to look a little bit weird, but they didn't give much room for our work here. So I'm going to do 1 squared minus 2. And if I think about that, 1 squared minus 2 is equal to, that's 1 squared is 1 times 1 equals 1 minus 2. So 1 minus 2 is negative 1. Okay, first one down. Let's look at the second one. So 2 squared, I'm actually going to make my pen a little bit more precise here. 2 squared minus 2. I do 2 times 2 to evaluate 2 squared, and that's 4 minus 2 equals 2. All right, we're on our way. 3 squared minus 2. 3 squared is 3 times 3, and that's 9. I still have my minus 2, and so 9 minus 2 is 7. All right, 4 squared minus 2. 4 times 4 is 16, minus 2 equals 14. All right, 7, we're jumping all the way up to 7. 7 squared minus 2. 7 times 7 is 49, and that is minus 2 equals 47. And then 9 squared minus 2 equals 9 times 9 is 81, minus 2, 81 minus 2 is 79. All right, something I want to just point out if you're listening closely here is that this does not appear to be linear. Plus 3, plus 4, plus 7, and so it looks quite different than a linear thing because it's not adding by the same thing each time. This is actually called a quadratic relationship, and we're going to talk a lot about that during our second semester. All right, plot points on the graph to represent the block pattern. So stack number 1, there are 3 blocks. Stack number 2, there are 4 blocks, and then 5 blocks. Okay, and I'm doing that because it says number of blocks here. Thankfully, it doesn't say number on the blocks. So stack number 1, we have 3. Stack number 2, we have 4. And stack number 3, we have 5. There we go. All right, find the value that makes each statement true. 3 plus blank equals 3. So you're adding something that doesn't change it, so it must be 0. 3 minus something equals 3. Again, the value doesn't change because 3 and 3 are the same, so we must be taking away nothing. All right, 3 plus something equals 0. So it's like we took 3 away. I know that taking away is like adding a negative, so 3 plus a negative 3 equals 0. All right, 5 plus 11 equals 11 plus, well, that's got to be 5. And this is called the commutative property. The commutative property says that you can reverse the order of addition and multiplication. So 5 plus 11 is 16, and 11 plus 5 is 16. So I know that I've made the right answer. Okay, so 3 plus something equals negative 3. Well, again, 0. The value didn't change. Negative 3 minus something equals negative 3. The value didn't change. That must be 0 again. 3 plus something equals 0. So if I'm thinking about my number line, here's 0, negative 1, negative 2, negative 3. I need something that takes me from 3 to 0, and that sure seems like I have to add 1, 2, 3. All right, 7 minus 1 equals negative 1 minus, it's pretty hard to think about negatives. So I'm going to do 7 minus 1, that's 6. And so I need negative 1 minus something equals 6. So I need to get the number larger. Negative 1 has to grow past 0 and all the way up to 6. So it's like I'm doing negative 1 plus 7, but there's a subtraction sign here. But I know that subtracting a negative is just like adding, so I'm going to do negative 1 minus negative 7, and I should get 6. So I think negative 7 goes down. Which you can check on a calculator if you want. Complete the following statements and answer the following questions. When you add 0 to a number, it doesn't change. And that's what we found up here. When you add a number to its opposite, it makes 0. And that's what we found here. 3 and negative 3 are opposites. All right, what is the relationship between A plus B and B plus A? And so if you look closely, that's just reversing the order. So I'm going to say they are the same. And that's what we found here, 5 plus 11 and 11 plus 5. What is the relationship between A minus B and B minus A? So let's think about that. It's a little bit more difficult to identify. I'm going to try some numbers. I'm going to try 5 minus 2 and 2 minus 5. 5 minus 2 is 3. 2 minus 5 is negative 3. I'm going to try one more set of numbers. 10 minus 8. 8 minus 10. 10 minus 8 is 2. 8 minus 10 is negative 2. It sure looks like it makes opposites. Or they are opposites, maybe a better way to put that. So if you do A minus B and then reverse it and do B minus A, you should get the opposite answer, the negative version of it. All right, that's our homework for today. Good work, everybody.